Okay, here in example 6, we've been given a graph to help us factor this polynomial, and so we don't have to necessarily solve, but we are going to at least factor it, and so we're going to use this picture to help us. And so, do we have any zeros by looking at this picture? Now hopefully you notice that yes, right here at x is equal to 2, we have a 0. Now, here's the trick to this problem. Do you notice anything special about what's happening at x is equal to 2? Hopefully, you're seeing that the graph is bouncing off of that x-intercept. And so remember back to section 2.3, what does it mean if the 0 bounces off of that the x-axis? It means that there is a multiplicity. And so there is a multiplicity here of 2, and maybe even more than 2, but definitely 2. And so that means we're going to synthetic divide by 2, not just once, but twice. And so that's the trick to the problem, is noticing that the graph bounces off of that x-intercept, and therefore you synthetic divide twice by that 0. So here we go. We're going to write down the coefficients of our given polynomial and start synthetic dividing first by 2. And so if I do this, I'm going to drop down the 3. 3 times 2 is going to give me 6. Add the column to get negative 5. 2 times negative 5 is going to give me negative 10, which gives me a 0 right there. 0 times 2 is, of course, 0, plus negative 4 is negative 4. And negative 4 times 2 is negative 8, which gives me the correct remainder. Now, from that line, I'm going to synthetic divide again by 2. And if I'm right about the multiplicity, we should get a 0 remainder again. So drop down the 3. 3 times 2 is 6. Add to negative 5. That gives me 1. And then 1 times 2 is 2. And so therefore, that's going to give me 2. 2 times 2 is 4. And there, once again, is the correct remainder. So what happened here? We started with x to the 4th. We synthetic divided once to get to x cubed. We synthetic divided again to get to x squared. And so therefore my irreducible quadratic is going to be 3x squared plus x plus 2. And then my other factor is going to be x plus 2. Sorry, not x plus 2. Let me hopefully erase that and try that again. X minus 2. And then what's the multiplicity of that 0? It's 2, and so therefore I need to put x minus 2 squared. And so here is my factored version of g of x using synthetic division, and then once again the fact that the graph is bouncing off of that x-intercept, which tells me about the multiplicity. Okay, example 7, we're given a function. We are basically going at the end of this to be asked to do two things: find all of the zeros and write it as a factored form with linear and irreducible quadratic factors. So what we're going to start off by doing, just like we did last time, is listing the possible rational zeros, or the PRZs. And so remember, in order to do that, we've got to list out our P's and our Q's. And P is the factors of the constant. And so here the constant is 20. Technically it's negative 20. I don't really care that it's negative at this point, because I know that here in a second when I go to write the PRZs, that I'm going to put plus or minus in the front anyways. And so I really just care that that it's a 20, not necessarily that it's a negative 20. And so what are my factors of 20? 1, 2, 4, and 5, 10, and 20. Okay, and then Q is the factors of the lead coefficient. And so the lead coefficient is 3. The only two factors of 3 would be 1 and 3. And so to find the PRZs, I know that I do P divided by Q. And so every P divided by each of the two Qs. So if I take all of those P's and divide by 1, I'm just going to get themselves right back. And then if I divide all of them by 3, I'm going to get 1/3, 2/3, 4/3, 5/3, 10/3, and 20/3. And so remember, this is a good starting point for me to actually find some zeros in the calculator, and that's what we're going to do next. Okay, in part B, I'm going to use the graphing calculator just like I showed you how to do in section 2.4 to determine which of the numbers on this list are actually zeros and then verify them using synthetic division. So I'm just going to tell you what they are and expect you to know how to do that in the calculator by now, but if you need help typing this function into the calculator and then finding which of these numbers are zeros, then please let me know. So from the calculator, what do we get as zeros? Well, we get x is equal to -4 and positive 1/3. And so what we're going to do now is we're going to take the coefficients of our function and we're going to synthetic divide. And so what are the coefficients of that function? It starts with 3, -1, -33, 71, and -20. Sorry, I couldn't read my own handwriting, so now I've got it. And it doesn't matter which of them you divide by first, so I'll just do the fraction first and drop down my 3, and so that's going to be 3 times 1/3, which is 1, plus -1 is 0, times 1/3 is 0, plus -33 is -33. -33 times 1/3 is -11. That's going to give me 60, and 60 times 1/3 is 20, which gives me a remainder of 0. Now I'm ready to synthetic divide again by the other 0, and so drop down the 3, multiply by -4, that gives me -12, add to 0, -12 times -4 is 48, plus -33 is 15, and 15 times -4 is -60, and that gives me the correct remainder there. So, as always, when I start with x to the 4th and divide once, I get x cubed. When I divide again, I get x squared. And so this is going to represent the polynomial, the quadratic 3x squared minus 12x plus 15. And so I'm actually going to pause here for just a second and actually do part C now, which says to write the function as a product of linear and irreducible quadratic factors. And so taking a look at my zeros, if I have -4 as a 0, that means one of my factors is going to be x plus 4. If I have positive 1/3 as one of my zeros, that means I'm going to have x minus 1/3, and then my irreducible quadratic is 3x squared minus 12x plus 15. Now, I don't really like the fraction here, this x minus 1/3, and I noticed that there is a 3 embedded into this quadratic. And so I'm actually going to take that 3 out of that quadratic and give it to this linear factor here just to make this look a little bit nicer. And so the x plus 4 is going to stay the same. When I give the 3 to that linear factor x minus 1/3, that's going to become 3x minus 1. So it's essentially like I'm just multiplying this middle linear factor by 3. And I took the 3 away from the quadratic, and so that's going to give me x squared minus 4x plus 5. And so that's the factored version of this as linear factors and irreducible quadratic factors, this little expression right here. Now go back to part B and let's finish solving to get the rest of our zeros. So we're going to take our irreducible quadratic and set it equal to 0 and solve. And so I need a solving method. This is clearly not going to factor because it being an irreducible quadratic, that means that it does not have real solutions. It has imaginary solutions, so therefore factoring is not going to work. So your choices are completing the square and quadratic formula. Since that middle term is even, I like completing the square, but quadratic formula would work just fine. If that middle term was not even, if it was odd, I would definitely prefer quadratic formula. So here we go. I'm going to start by taking half of that middle term, which is 2, and squaring it, which is going to give me 4. I'm going to go ahead and move the positive 5 to the other side, which is going to give me -5. And since I added 4 to the left-hand side, I've got to also add 4 to the right-hand side. On the left, this now factors. Factors of 4 that will add to negative 4 are going to be x minus 2 and x minus 2. So x minus 2 squared is equal to negative 5 plus 4 is going to be negative 1. Take the square root of both sides, and so that's going to give me x minus 2 is equal to plus or minus the square root of negative 1, which is going to be I. And then solve for x, and I get x is equal to 2 plus or minus I. And in addition to that, the other two zeros which I received from the calculator, which were negative 4 and 1/3. Okay, example 8, we are going to bring everything together and work a couple more examples where we find all of the zeros and then write the function as a product of linear and irreducible quadratic factors. So the first thing is I want to find the PRZs. So I'm going to find my P's and my Q's. P is going to be the factors of the leading coefficient, which is 15. And so that will be 1, 3, 5, and 15. Q is the factors of the leading coefficient, which is just 1. And so the only factor of 1 is, of course, 1. And so my PRZs, my possible rational zeros, are going to be plus and minus all of the p's divided by 1. So that will be 1, 3, 5, and 15. Okay, using the calculator to figure out which of these actually are zeros, by using the table, it's going to tell you that x equals negative 3 is the only number from that list that is a 0. And so once I have that, I'm ready to start synthetic dividing. So listing my coefficients, drawing my horizontal and my vertical line here, and dropping the first number down, and multiplying. 1 times negative 3 is negative 3. Negative 3 plus 1 is negative 2, and negative 2 times negative 3 gives me 6, which gives me 5, and 5 times negative 3 is negative 15 for a remainder of 0. And so this was x cubed. We divided once. That got us down to x squared, and so this is the quadratic, x squared minus 2x plus 5. That's going to be my irreducible quadratic factor. And then my linear factor, because my 0 was negative 3, my linear factor is going to be x plus 3. And so there is the function written as the product of a linear and irreducible quadratic factor. Now, I still need to find the zeros. So I know that one of my zeros came from the calculator. That's where that linear factor came from right there. But I need to find the zeros from my quadratic factor. And so I have x squared minus 2x plus 5. I'm going to set that equal to 0 and solve. And once again, because that middle term is even, I prefer completing the square, but quadratic formula is perfectly fine as well. So x squared minus 2x, we take half of the 2 and square it, and so that would be 1. And when I move that 5 over, it becomes negative 5, and I've got to add 1 to it as well, since whatever I do to the left, I've got to also do to the right side of the equation. So on the right-hand side, that's just negative 4, and on the left-hand side, this is now going to factor. Factors of 1 that will add to negative 2 would be negative 1 and negative 1, and so this is going to be x minus 1 squared. I take the square root of both sides, and that leaves x minus 1 is equal to plus or minus the square root of negative 4, which would be 2i, and then just add 1 to both sides so that we get 1 plus or minus 2i. That's 2 of my zeros, and then don't forget about the third one, which came from the calculator, negative 3. Okay, one more example for your notes, and then I think you'll be ready to be successful on your practice and your quiz and your test. And so, once again, I'm going to find my possible rational zeros by finding the p's and the q's. P is the factors of the leading coefficient, which is 4, and so that would be 1, 2, and 4. And q is the factors of the lead coefficient, which is just 1. And so that makes my possible rational, I don't know what I'm writing here, not PRQ, PRZs, positive and negative, all of the p's divided by 1, which would be 1, 2, and 4. Okay, so using the calculator to figure out which of those 6 numbers are zeros, what you're going to end up with is x is equal to 1, and negative 4, and so I've got 2 zeros to divide by here. And so setting up my synthetic division, I'm going to have 1, 3, negative 3, positive 3, and negative 4. Again, it doesn't really matter which of the zeros you divide by first. So since I'm a positive person, I'm going to divide by positive 1 first, and then drop down the 1, multiply by 1 to give me 1, add to 3 to get 4. 4 times 1 is 4, plus negative 3 is 1, times 1 is 1. That gives me another 4, times 1 is 4, and a remainder of 0. Now, keep going. Synthetic divide by the other 0, which is negative 4. Drop down the 1. 1 times negative 4 is negative 4. That's going to give me a 0 right there on my last line, which is going to give me a 0 there. Plus 1 is 1, and then times negative 4, and I get my remainder of 0. Now, one last time, when I start with x to the 4th and divide once, I get x cubed. I divide again, I get x squared. So my my irreducible quadratic factor is going to be x squared plus 1. One of my linear factors is going to be x minus 1, and the other linear factor is going to be x plus 4. And again, that's determined by these zeros that we got out of the calculator. Now, the last thing is to find the 2 remaining zeros, and so that is taking my irreducible quadratic and setting it equal to 0. And here, square root method is going to be the ticket to success. And so take the square root of both sides, I get plus or minus I, and that is in addition to negative 4 and positive 1, which we got out of the calculator, for a total of 4 zeros, which by the fundamental theorem of algebra is exactly the number we were supposed to have. Okay, if you have questions on section 2.5, please reach out to me, and if not, then have a great day.